Let's take a look at the quotient rule. You should memorize this. There are songs on YouTube if you want to look them up, but really this is what you've got. So if you have a quotient, something divided by something, the derivative is f prime g minus fg prime divided by that denominator squared g squared. In this first example, we've got x squared over sine x. I want to go ahead and apply the quotient rule. Order is really important. So notice as you're taking the quotient rule, the very first term that you come to in that numerator is the derivative of f, the derivative of that numerator. So let's go ahead and do that. I'm going to write this as x squared prime. I'm going to take the derivative in the next step so you can see how I'm piecing all of this together. And then times g, so I'm leaving that one put. So this is the sine of x. And then I want to do minus f times g. So we're going to go ahead and leave x squared. So x squared, and then the derivative, I'm just going to write that as sine x prime. And then my denominator is just g, the denominator squared. So we end up with parentheses sine x squared, or you can throw the squared on the sine. I'll do that in my next step. So continuing here, let's go ahead and work out that numerator. So the numerator is x squared prime. That's going to give me a 2x. I leave the sine x, so that's g, so times sine x. And then minus x squared, and then I want the derivative of sine, which is cosine, so cosine x. And then that denominator, I am going to write this as sine squared x. Now, this is my answer. I could do some cleaning up, just really rewriting it. I could also, if you had to simplify this and take it to a next step, you could write this as 2x sine x divided by sine squared. And you can simplify this term by term. So x squared cosine x. One of the tricky things about trig answers is there are so many different ways that you could write them. I'm just going to put dot, dot, dot here so you can see how you can simplify and keep going. But we've done the quotient rule here. Let's do a second example. In this next one, I've got the derivative of tangent. You might have this one memorized as secant squared. If not, this is a really great one to show you how the quotient rule works. So I'm going to rewrite this one as sine over cosine. So it's going to be the derivative of sine over cosine. So sine is going to be f, that's going to be my numerator, and then g is cosine, so that's going to be my cosine. So working through this derivative, I'm going to apply my quotient rule next. So leave myself some room, and I want the derivative of sine, so sine x prime times the denominator unchanged, so times cosine x. Minus comes next, and I'm going to leave the numerator, so sine x, and then take the derivative of the denominator, so cosine x prime, and then in the denominator we've got cosine squared x. Now as I continue to simplify, a lot of really nice things happen. The derivative of sine is equal to cosine. So in this first term, I have cosine times cosine, which is cosine squared. So we'll write that as cosine squared x. In the second term in my numerator, the derivative of cosine is negative sine x. So I've got these two negatives. Negative times negative is positive. Sine times sine is sine squared x. I hope you recognize cosine squared plus sine squared as the Pythagorean identity. That guy is equal to 1. And we end up with cosine squared x in our denominator. So we get 1 over cosine squared x. Also known as, let me put my answer up here, also known as secant squared x. Let's do another example. In this next example, I again have a quotient, but this time it's a polynomial over a single term, over a monomial. So this one is so much easier if we simplify first. So whenever you can simplify first, do that. You don't want to use the quotient rule unless you absolutely have to. Let's rewrite this one. So I'm using prime notation here. So I'm just going to leave this in parentheses. I can actually split this up and divide both of the terms in the numerator by the x squared. So rewriting this, I get 3x cubed divided by x squared, bring that plus sign over, and then I have a 5x divided by x squared. Simplifying this, I can cancel the 2 x's in the denominator with 1 in the numerator. That's going to give me parenthesis a 3x. In the second term, I can cancel the x in the numerator. That's going to leave me with a single x in the denominator. Now, I could write this one as 5 over x, but instead I want to use a power rule, so I'm going to write that as plus 5x to the negative 1. I still need to take this derivative, so I'll put the prime outside. I am ready, though, to take the derivative. The derivative of 3x is 3, and then taking the derivative of 5x to the negative 1 is going to be plus 5. I'm really just doing the derivative of x to the negative 1. So that's going to be negative 1, x to the negative 2. So what do we have? We've got 3 minus 5, x to the negative 2, which you could also write as 3 minus 5 over x squared. Okay, here's your challenge. This one's for you, the derivative of e to the x over tangent x. So I'm going to give you a hint in a second. I'm going to give you the derivatives of e to the x and tangent x. If you don't need those, pause right now and then come back and see how you did. If you do need those, here comes those derivatives. So the derivative of e to the x is just itself. You are welcome. That one's e to the x. And the derivative of tan x is secant squared x. Okay, pause the video, take that derivative, you're going to do great, and I'll see you in a minute. Okay, so we are back. Let's see how you did. The numerator is f, that's e to the x, and our denominator is g, and we've got the derivatives right next to them. Let's go ahead and take that derivative, applying our quotient rule. So I'm going to start with the derivative of f. The derivative of e to the x is e to the x, and then I want tangent just left alone, so times tan x. Minus in between. Next comes f just as is, so that's going to be e to the x. And now I take the derivative of tangent, which is secant squared x. In my denominator, I'm going to square that tangent, so I get tan squared x. Sometimes you'll have the correct answer, but it won't match the back of the book or whatever your program is giving you because there's still some simplifying to do. So what we need to do to simplify it is to divide each of the terms in the numerator by that tan squared. So I'm going to split this fraction up, and we're going to write it as e to the x tan x divided by that denominator, tan squared. And same with the second one, so minus e to the x secant squared x divided by that denominator, tan squared x. Now we need some more room, so let me move this up. So as I continue, I can cancel a tangent in that first fraction. So I can cancel this tangent. That's going to leave me with e to the x divided by tan x, e to the x divided by tan x. Now, in the second fraction, it's not clear because of the form, but I can do some canceling if I get everything into sines and cosines. So I'm going to leave the e to the x. The secant becomes 1 over cosine squared x. And the tangent squared is going to become, well, it's in the denominator, so it's going to be a reciprocal. So that's going to be cosine squared x over sine squared x. So as I follow those through, the secant is this one, the tan squared is that last fraction. Now, how nice is this? I can cancel these cosine squareds. Here comes one form of our answer. So I get e to the x divided by tan x minus e to the x, and I'm left with the sine squared in the denominator. So this would be one form. With trig, there are so many different forms. This one might be great. You could also, if you wanted to simplify it and not have denominators, you could write it as e to the x cotangent x minus e to the x, that would be a cosecant squared x. So many different ways. We actually had our answer way back here A lot of our work in these derivatives in the calculus is the algebra and the trig. Very little of what we end up doing is the calculus. I know you're doing great. Keep practicing. Watch my next video. I'm going to show you how to work through the chain rule, and take a look at my other videos as well. You've got this.